So today we are going to be learning how to deploy an elastic load balancer with an auto-scaling group. We are going to focus on setting up a load balancer that will have health checks for our instances, determine if we can access those instances and will be appropriately routed evenly using our load balancer. And we will also set up an auto-scaling group and scaling policies to increase our instances in response to maxing out the CPU utilization. And then if we wait some time, we should also see the scale-in policy kick in and bring our number of instances back down to normal. So without further ado, I'm already logged into the AWS Management Console, and we are going to go ahead and get started. So first things first, we need to create a launch template. A launch template determines what our EC2 auto-scaling group will actually launch. So you should see this landing page or something similar if you've already used it. We're going to select Create Launch Template, and then give it a name. In this case, I will just give it my last name, -launch-template. And then we don't necessarily need to worry about a description here. And yes, we want to be provided guidance to set up a template that we can use with our scaling. And we don't particularly need any tags, nor do we really need a source template either. The AMI that we'll be using is the Linux 2 64-bit x86 AMI, which is also the default for the T2 Micro instance. Our instance type will be T2 Micro to stay in free tier. And in this case, we're going to go ahead and create a new key pair to access our instances. So I'll just call this something like launch template. And we now have that key pair created and downloaded. We want to launch into our VPC. And in this case, I'm going to use my Launch Wizard 1 security group, which already has SSH and HTTP open on port 80. Again, we can keep our volumes as the default. And we'll go ahead and use a resource tag to name our instances. So I'll call it name, and our value can be something like ASG for auto-scaling. We'll just call this auto-scaling. And lastly, we don't need to worry about network instance interfaces. But we do want to provision our EC2 instances as web servers, so we're going to run our updates and download Apache and set up a default landing page. Again, we can keep all this as default and change our user data here to this file that I have created. So we'll run our updates, install Apache, ensure that it's on and will be on if we restart our instance, change our directory, and create a default index.html file that will display when we connect to our instance for the first time. And we can go ahead and create this launch template. Notice it'll give us our success message, and then we have three options. We can either launch an instance, create an auto-scaling group, or create a spot fleet. In this case, we are going to go ahead and create an auto-scaling group. So we will open that up, and again, it will prompt us for a name. I'm going to use my last name -auto-scaling, and it again prompts us to use our launch template. Now, previously, you could use launch configurations, but launch templates seem to be the new and preferred way of creating these templates for AWS. So we're going to stick with our template that we've created. It's the default version 1 because we haven't made any changes. Again, we can see that it's using our launch template T2 Micro instances. This is the AMI for Linux 2. And then we have the security group that we chose as well. So we can go ahead and select Next, and we can adhere to our launch template. We don't need to worry about spot instances at all. We're just going to use the normal on-demand ones. It's going to use our default VPC. Again, if you had a separate one or a second one, you could go ahead and choose a different VPC. And we can choose our subnets. To make it easy, I'm just going to select 1A, 1B, and 1C so we can load across those three subnets. Following that, we want to create a load balancer. So if you have an existing load balancer, you could attach it. In this case, we are going to attach to a new load balancer. We're going to use an ALB since this is going to be primarily web traffic, and we're going to have it be internet facing so that we can create an endpoint through which we can connect. Again, it'll automatically choose to load balance across the three subnets that we set up for our auto-scaling group. If for whatever reason you decided to add additional subnets, you can do that, but we have three subnets in our ASG, and those are the subnets, or three subnets in our previous scaling group, and we're just going to use those subnets with our load balancer. Again, we will be using listeners over port 80 on HTTP, and in this case, we will need to create a target group to default our routing to, which will prompt us in a second. We will also turn our health checks on, and then In this case, this is a 5-minute grace period. We can actually drop this down to about 3 minutes since our instances get set up pretty quickly. So if we click next, it should prompt us to create this target group, and it does. So we need to go ahead and create a target group. In this case, it'll automatically just set up one with the name of our original auto-scaling group and just put -1. So we can go ahead and hit next. And here we can set our desired capacity, our minimum capacity, and our maximum capacity. In this case, our minimum has to be 1, I believe. I don't think we can set it to 0, or in this case, actually, we can. So we can set it to 1. I want our maximum number of EC2 instances to be 3, and we will set our desired capacity at 2, or at 1. One thing to note is that the desired capacity will actually fluctuate in response to our target metric. So keep an eye out if you are expecting it to scale back into 1, and you're noticing that it's set to 2 or 3, you may need to manually adjust that desired capacity if you would like the scale in to trigger faster. In this case, it's going to give us an option to set up our scaling policies. We want to go ahead and do that. We want to use target tracking scaling, and we want to track it on the average CPU utilization. In this case, I'm going to set it from 50 down to 30, and the reason is because we will max out one of our instances CPU utilization to 100%. 100% divided by 3 will enable us to hit 33%, which is around our target value. So it'll fully expand up to our 3 maximum. And then the instances need how many seconds to warm up before being included in our metric. We'll give them 2 minutes to warm up before they're actually included. And then in this case, we also have the option to disable our scale-in. We don't want to do that. We do want our instances to scale back in if our CPU utilization is reduced, which it will be after we stop our instance maximizing from occurring. So we can go ahead and hit select next. We could choose to set up an SNS notification. I'm not going to do that now, but if you want to be notified when there was an activity taken in your auto scaling, then you could do that. And last but not least, we can choose to tag our instances. I believe if you tag the template here, so it'll be overridden. It'll override our launch template, so we don't necessarily want or need to do that. And again, it's just giving us a nice review. So we're using our launch template we set up in our default VPC across our 3 availability zones. And we also have our load balancer ready to go. We have our desired capacity, our minimum, and our maximum set. We're going to use target tracking scaling. We want to keep our CPU utilization at around 30%. And we will give them 2 minutes to warm up before including them in our metric. Great. So now that we have our auto scaling group, notice that it's saying the status is updating capacity. So it's actually going to start launching some instances. And then in response, we will see that it will kind of give us an activity notification. So if we look at our details, we can see the information that we just put inside. And then in our activity here, we will see that it said, at this time, a user request created an auto-scaling group that changed the desired capacity from 0 to 1. Therefore, we are starting an instance in response to that to increase the actual capacity from 0 to 1. So we can take a look at that on our EC2 dashboard. And we can see that we now have 1 running instance, and it's being initialized. So because we said that we have at least a desired capacity of 1, it triggered to launch an instance named auto-scaling as we set up in our launch template. And if it's had enough time, we should be able to connect to its public IP and see our web page. It may still be booting up. So we can see that it's still taking some time to actually establish that connection. So we can just keep refreshing and see when our status changes to pending. It's again still initializing that first instance, but we can see that now it is actually refreshed and connected. We can see that it set up Apache and it's delivering our web content set up as your first name and last name with the instance and this default # sign. So right now it is tracking our average CPU utilization, which should be around 3% or so. This instance is basically running with just my connection here, and there's no other traffic coming to it. We can also check that our load balancer is running properly by examining the endpoint and the health checks. So we can see we have created our load balancer, and we do have our DNS endpoint here. So let's take a look, and it forwards us exactly to our first instance that we've launched. We can also take a look at some of the listeners here. We have our HTTP listener set up. We have our monitoring set up. There's not enough time yet for it to show any data, but we can take a look at our specific listeners that we've created. So if we look at our group details, we can see that it requires 5 consecutive health check failures and 5 consecutive health check successes to be either considered healthy or unhealthy. We can actually modify this. We can keep this health check path of the default. And in this case, let's change the healthy threshold down to, say, 3. And we'll change our unhealthy threshold to 2. And then we can say if there's no response within 5 seconds, that means it's been a failed health check. And then we can change this from 30 seconds, and let's say we want to send a health check every 10 seconds. And then we only need 20 seconds for it to be considered unhealthy and 30 seconds to be considered healthy, and it will send it back with a 200 HTTP response code. So we can go ahead and save those changes, and we can take a look at the targets. So there should only be one instance right now that's targeting. If our auto-scaling group launches more, then those will also be registered as targets, and we can see it's passed those health checks for now. And we can also take a look at the monitoring here. We can see that there's one healthy host at the moment, and then given more time, we can see that there are some errors once we start maxing out our instance. So to actually cause our auto-scaling group to trigger, we need to increase the CPU utilization. Now to do that, we can go ahead and connect to our instance, and I will use EC2 instance connect for ease. And if all goes well, we should be connected. So now I'm going to run a quick command that is while true, do echo done. And what this will do is run 3 separate commands, or essentially one while loop that will say while true. And in this case, it'll always be true since we haven't changed it. Basically echo nothing, and then done simply closes the while loop. So this will essentially run a while loop into infinity, which will cause our CPU utilization to dramatically spike. So I will go ahead and hit enter, and then I will pause for a couple of minutes to let our CPU utilization max, and we will examine the results of what has happened. We've given it a few minutes now for our instance to max out the CPU utilization using that infinite while loop. So let's go ahead and close this connection and see what's happened both in our EC2 instance console and also on the auto-scaling group activity side. So with the EC2 management console, or with the auto-scaling group activity side, we can see that a couple of events have happened. So first, we again launched our first instance because we said the minimum capacity was 1 and our desired capacity was 1, so we went ahead and launched an instance. Then our infinite while loop caused our CPU utilization to go above that 30% average metric, so it triggered the creation of another EC2 instance using our launch template. And we can see that it was in the alarm state here, and that triggered our policy to change the desired capacity from 1 to 2. And then again, because our CPU utilization kept climbing, so it should be maxed out at about 100%, that caused our utilization to climb above a 30% average. So if it's above 60% for one of those instances, then that's over 30% average because we would have divided by 2. Now we're up to 3 instances. So again, that causes the creation of another third instance. So in reality, our CPU utilization should be around 33% per instance. So 100% CPU utilization on one instance, basically 0 on the other 2. So that divides to about 33%. But because our maximum was set at 3 instances, we don't get a 4th instance being launched, even though our CPU utilization metric was above our mark that we had set at 30%. So great, it says it launched 2 instances. Did it actually? Well, we can check. If we go to our instances, we can see that we do in fact now have 3, and we can see that they were properly load balanced. We have 1 in 1A, 1 in 1B, and 1 in 1C. And if we go ahead and check those public IPs, we can take a look. So our first one was this 3.86 number. Let's take a look at our second instance here. We can see that it also was set up correctly using our launch template, and then we can investigate the third public IP address, which begins with 34, and we can see that it was also set up correctly as a web server. Now we can refresh through with our ELB, but that won't actually tell us anything. It won't show us if we're properly being load balanced or not. So we want to change this pound symbol to actually represent a number. In this case, I'm going to call it 1, 2, and 3. So let's go ahead and SSH into our 3 instances and try to change that from this pound symbol to 1, 2, and 3. So very quickly, we are simply going to connect into each one of these. So we're going to connect, and then that should load up, and then we are going to type cd var www html to connect to our HTML, and use nano to edit our index.html file, and we will just change this from a pound to a 1. Whoop, we forgot to be in sudo. So let's go ahead and clear our screen, go into our root privileges. Now we can actually edit the file, and we can change this from a pound symbol to a 1, Control X, Y, enter. We can go ahead and close this connection. So this was our 34 IP. Let's go ahead and make that exact same change for the other ones. So for our second instance, we will go ahead and also change its index.html file. So sudo su, change directory, and then we can go ahead and change this file as well. We'll call this instance 2. Close out our connection here. So this was the 3.86 instance. And then now we simply need to go to our final public instance, which begins with 3.87. We will go ahead and connect in, get root privileges, change our directory, and use nano to change this to instance 3. Now that we have made this change, we should be able to use our load balancer and see this is instance 1, instance 2, and instance 3. And we're actually being cycled through in that exact order, which indicates our load balancer is functioning correctly. And again, if we were to go to the IPs of those instances directly, we can see it's indeed instances 1, 2, and 3. So we can just go ahead and put these in order. We have 1, instance 2, and instance 3. Excellent. So what happens now that our CPU utilization is starting to go back down? Well, if we wait some time, we should see our scale-in policy actually go into effect at the moment. So right now, we can go ahead and take a look at our load balancer. And if we look at our target groups, we can see that we should have all 3 of our instances being listed as healthy, hopefully. So we can see that we do have 3 healthy hosts. We can see the number of requests. That's us kind of cycling through on the load balancer. We can see that there was one unhealthy host for a time, which would have been the instance that had its metric being too high. And we can see that we have 3 consecutive health check successes as our metric. So everything looks good on our load balancer end. And if we check our auto scaling group, we can see right now that our desired capacity still sit at 3. If we wanted to trigger the scale-in policy faster, we could actually manually change this down to 1. So we can say we adjusted any of our high CPU utilization issues, and we can cause this to drop back down to 1 for our group size. So let's go ahead and hit update, and we can take a look at our activity. And then if we were to wait some time, it would eventually change to reflect that we are going to terminate one of our instances. So I will again pause, and we will take some time to see if it impacts our scaling policy. Okay, so we waited a few minutes, and we saw that there's actually now a couple of new activities, or a new activity history in our auto scaling group. So we can see that right now we had a user request to change our desired capacity from 3 down to 1 instances. So that's essentially just a way of speeding up our scale-in policy to manually dictate that we want to drop our instances back to just 1. And it'll say that we took an instance out of service in response to a difference between that desired and actual capacity. and it essentially did that twice. We had 3 instances running. We requested that we only have 1, and so it terminated 2. And we can see that it's saying it's waiting for the ELB connection draining. It's basically saying we want to make sure that we're not terminating an instance while there's still a live connection. So if we actually go ahead and switch it back to instance 1, that should try to solve that problem. And if we look now at our refreshed activity history here, we can see it's still taking time to go through that draining process. So let's take a look at what that is on the load balancer side. So if we click on our ELB, actually let's go ahead and close our ELB just to make sure we don't have any connections in process that might impede that draining process. So let's go ahead and close that out. And let's take a look at our listeners here. On our target group side, we can see that we did have 3 targets, and it's deregistering those targets right now. So we had 2 instances basically be scheduled for termination. One quick note about termination and scaling policies: it will default to terminate the oldest instances first. So in this case, the newest instance, or the oldest instance, was 1A. The second oldest was launched in 1B, and the newest was launched in 1C. So it will delete those older instances first and retain the newer one. On our monitoring side, we can see what that looks like with some of our CloudWatch metrics. Again, we have our healthy hosts, and we had 3. Now we're dropping back down to have 1 healthy host. We can see that we have some responses over HTTP. We have our 200 status health checks. And so it's basically going through that process of deregistering all of our instances from the ELB, draining those connections, and then eventually we'll actually terminate them. So we can see if it's made any headway there, and now it's in progress of actually terminating that EC2 instance. So just to make sure, we will go ahead and close out of this instance as well to make sure there are no lingering connections. That seemed to have done the trick. We are now in progress of terminating both of our instances, and we can confirm that that is the case by going actually to our EC2 console, and we can see that there are 2 instances now being shut down. That leaves us with just 1 more remaining. All right, so hopefully this was a useful tutorial on how to successfully create a launch template and create an auto-scaling group and a load balancer to deploy instances in response to a target metric. In this case, it was CPU utilization. We saw that we could quickly and easily set up a load balancer to divert or easily divide that traffic among our instances that we launched. We saw that our instances would be launched in response to a change in CPU utilization that we achieved by maxing out our instance using an infinite while loop. And then we saw that we could manually trigger in our scale-in by changing our desired number of instances from 3 back down to 1, which causes those connections to be drained. And once we terminate those instances or terminated those connections, our instances were terminated in kind. And if we refresh, we should now see that it is all successful. So again, we created our load balancer, launched our instance, launched 2 more instances in response to our metric being triggered on using CloudWatch, and then we saw that our instances were triggered or terminated in response to our desired capacity being updated from 3 back down to 1. And lastly, we can see that using our load balancer, it should have successfully deregistered those targets, so we would never have been routed to an unhealthy instance. And we should see that the only instance we're getting routed to is now instance 1. So again, load balancers are particularly helpful because you can configure them to use those health checks so that if an instance is unhealthy for whatever reason, in this case we specifically terminated them, we don't keep getting routed to a dead endpoint. So thank you for following along, and let me know if any of you have any questions.